In this video, we're going to look at periodic functions word problems, but we're going to do word problems where we're given the equation. So we're starting with this example where it says the height h of a seat above the ground on a Ferris wheel at time t is given by the function h of t equals negative 35 cosine pi over 5t plus 40, where t is seconds and h is feet. So we're going to graph the function and find the maximum height, and we're going to answer how long it takes us to make a full revolution. So the first thing to recognize is that this value right here is our midline. That's the value that our function is going to go above and below. Okay. Then the amplitude here is going to be 35. This a value right here, we call it the amplitude. That means we're going to go 35 units above it all the way up to 75, and 35 units below it all the way down to 5. So even this early, we're able to answer this question. If it says find the maximum height of the seat, it's going to be 75 because we had a midline of 40 and then we went 35 feet above it. Now, let's talk about the period, and this part's a little bit trickier. Basically, this would answer this last question, how long it takes us to make a full revolution. It says, to find the period, our little equation for that is take 2 pi divided by the b value, with this being the b value right here. So to do 2 pi divided by b, I'm doing 2 pi divided by pi over 5. Well, to divide those, I'm going to flip the second and multiply. That's equal to 2 pi times pi over 5. Notice I just took this and I'm multiplying by the reciprocal. Pi over pi will cancel, and 2 times 5 is 10. So it looks like this will take us 10 seconds. It takes 10 seconds to get all the way around here. So I'll mark 10 seconds on my graph, and then I'll also like to mark kind of halfway because that will help me graph our function. So now I think I really have all that we need. So we know we're graphing a cosine function. So cosine does not start on the midline. Cosine typically starts at a peak. If this was 1, our cosine graph would go, hit 0 down to -1 and then end back up at 1. But we have our amplitude of 35, but also the negative means we're going to reflect our cosine graph. So instead of starting at a peak, we're going to start at a valley. So if I'm going to start my graph right here, but then we know it's also going to end right here at 10 seconds because it takes 10 seconds to complete the full period. And then we know that halfway through it must be at a peak. So our graph of this function would look something like that. Okay? I didn't draw it great, but it's supposed to be symmetrical. So we're going to look at our second example. It says the temperature on the surface of a lake X hours after midnight is given by this function. Now, the first thing that I want to discuss is the form that this function is in. It's got this minus a value right here, and you might be thinking that that is the horizontal shift if you're familiar with basic transformations. But what's a little bit weird about it is that our b value is in here next to the x, but within the same set of parentheses. But what we need to know is that whenever we're looking at this horizontal shift, this c value is only the horizontal shift when our function is in this form. Meaning I need to factor the b out of these two terms. I need to divide by pi over 12 here, and I need to divide by pi over 12 here. Well, what that's going to become, and I'll kind of do some aside work right here, y equals 15 sine. Well, I'm going to factor out pi over 12 x minus, but we got to figure out how to factor pi over 12 out of 2 pi over 3. Well, whenever you're factoring a value, you're really just dividing it. So if I take 2 pi over 3 and I'm dividing by pi over 12, that means I'm really multiplying by 12 over pi. So if that cancels and we end up with 24 over 3, 24 over 3 is 8. So here is the function that we're actually going to have to graph. This is our horizontal shift. We're shifted to the right 8 units. So I'm about to make all this work go away for the rest of the problem, but I want you to recognize if your function's in this form, in order to identify the horizontal shift, you're going to have to factor this value out of both of these terms, kind of like undistributing the pi over 12, and then your function will look like this. Okay? Now, we've got our function in the form that we want, and we're ready to start identifying our attributes. We have a midline of 50, okay? That means our temperature is going to kind of have an average temperature of 50, and it's going to go 15 degrees above that and 15 degrees below that. So 15 degrees above 50 would be 65, and 15 degrees below would be 35. So our maximum temp in this situation would be 65, and our minimum temp would be 35. Now let's calculate our period. We know period is 2 pi over b, which our b value is pi over 12. So if I divide 2 pi by pi over 12, I'm just going to flip the second and multiply. So instead of dividing by pi over 12, I multiply by 12 over pi. Pi over pi cancels, and then 2 times 12 is 24. And you might go, oh, that makes sense. You know, within a day, 24 hours, that's how long it would take to kind of complete our full cycle. And so I like to mark 24, and I also like to mark the 12 on my graph, knowing that's halfway. But we still haven't really factored in this horizontal shift of 8 units, and I want us to think about that. If we're shifting 8 units to the right, that means that instead of starting at 0, we can start our sine graph at 8. And instead of it finishing in 24 hours, which is the period, it's going to finish at hour 32. We've shifted our entire graph to the right 8 units. But now that I've done all the legwork, I think we're ready to graph our function. So we know that sine is going to start on the midline, and as we've already established, I'm going to start at the 8th hour because we shifted to the right 8 units. I'm going to finish at the 32nd hour. And so then it helps me to also identify what kind of the midpoint would be. So if I shifted my 8 units to the right, we know that at hour 20, we'd kind of be halfway, right? So our sine function is going to look like this. It starts here. It's going to hit a peak. It's back down to the average temperature. And then it's going to dip down below. And then it's going to finish up its full period by hour 32. So from 8 to 32 is still 24 hours. We've just shifted it to the right 8 units.